That's for the beta role.
So welcome to another episode of Beta Talk. So today I'm out and about. I'm at the Qvantum offices. I'll tell you how to spell that in a minute. It's not a QU, it's a QV. And I'm with Philip Ord, who's UK Managing Director. That's right, Philip, is it? And then I'm with my friend Thomas Nowak, who some of you may know from his days when he was the General Secretary for the European Heat Pump Association. Because you've been at Qvantum for how long, Thomas?
A year and a half about.
It's a year and a half. What is your role? Because obviously, Philip, you're UK MD, and there's probably 5 countries that use the Qvantum stuff, isn't it? It's a Swedish company.
That's right. And the headquarters and the 5 countries, they share one person to look into government relations and public affairs, and that's what I do.
Because you're good at that, aren't you?
I hope so.
Because I think you were 18 years at the European Heat Pump Association?
Yes, 17 and a half in fact, but it's very close to 18.
And do you miss it?
Well, I wanted a different job, so I should not say I miss it. I do miss the team as it was, and I miss the way that we were able to shape policy, and it's good to see that it is actually now recognized, so that I think EHPA is an acknowledged partner in the discussion in Brussels, gets inroads into many of the debates that we are having on the competitiveness of industry and on the decarbonization of heating and cooling. Also, the big heat pumps are recognized, and system integration, lower electricity tariffs, for example, is now on the top of the agenda in Brussels. So you could say that would have been easy to continue with. But I also think that it was a good point in changing my job, because I wanted to have hands-on experience on the ground. And I'm actually very happy to see that Paul Kenny, my successor, he stepped in very, very quickly, and he's now doing the job. So we have put somebody else in that position, and I can do something new.
I was out for dinner with Paul a couple of weeks ago. I like Paul. So what made you come to Qvantum? Obviously you saw something in Qvantum that you quite liked. Yeah. And I imagine, is that the ambient loop stuff?
That's part of it. My conclusion after 17 years, actually after 16 and a half years, I was at a conference where I was giving a presentation, and my brain was thinking, should I do another 10 years of these presentations telling people that have woken up just now about heat pumps, or should I try to do something else? And I thought that at that time, that was before the end of the last Commission mandate, that we were quite good at positioning heat pumps into the political landscape. And I thought maybe we are done. Maybe that was a bit too optimistic if we see what happens now after this right-wing swing in policies, that there's still a lot of work to do. But my conclusion at that point in time was that I do not want to explain again what heat pumps are for the next 10 or 15 years. And the overlooked part of the discussion was always the multifamily buildings. And then, of course, when you think of multifamily buildings, you end very quickly at a point where you say, where do I get the energy from? Especially when you look at a city like London. And the typical answer would be, you take a district heating system, high temperature, and then you just feed that high temperature heat into the building, and then you heat the apartments, and you're done with. And when I met Frederick, and he told me first about these ambient loops, which was at that time, because he was at E.ON, was called Ectogrid, but that's a brand name. So the idea of putting 2 pipes uninsulated into any type of structure, it can be a building, but it can be a street, it can be a quarter, it can be a whole city, and then making that heat available as heat source for small water heat pumps, and also being able to provide heating and cooling and collecting the waste heat from cooling. That I thought was so attractive. This is one of these things, when you see them once, you cannot stop thinking all the time, where could I deploy that? And now, whenever I see an air handling unit or a water cooler on a roof, I'm thinking, you're wasting energy. You are literally wasting energy. Why are we not putting such a grid into the city, and we say, okay, everybody that needs cooling, which is more and more people and buildings have that need, they need a permit. And if they cannot prove that there is nobody to use that waste heat, then maybe they can use their air coolers and water coolers. But if there is somebody else that wants that waste heat, then you have to put it somewhere, and this infrastructure would be an ambient loop. So yes, indeed, seeing this, which is half of Europe's heat demand, or half of the residential heat demand is in multifamily buildings, seeing that completely unaddressed, I thought this is actually a very noble challenge to put my energy on. And then when I was given the opportunity, I said yes.
Just before I move on to Philip, was Frederick chair of the Swedish Heat Pump Association?
No,
he wasn't.
No.
That's all. So we're talking about these ambient loops. Philip, obviously your background is heat pumps because you come from a very well-known air-to-air company. I think you were there for 20 years, I think.
Yeah, more than.
So the ambient loop is what really interests me, and serendipitously, I arrived here today as Charlotte, the CEO of the Heat Pump Association, was doing a bit of CPD. She wanted to come and learn a little bit more about that as well, so I think that was brilliant. Is there a country in Europe that's getting this right? I mean, Thomas, you might be able to answer this as well, but is there I mean, I'm going to say Sweden, because obviously this is where your brand is from. Are there any European countries that are getting this ambient loop, sort of fifth generation, some people call it, right?
I think if you look at the Swedish market, it's mainly the district heating in Sweden is mainly high temperature. Gothenburg is high temperature. Exhaust air heat pumps are very dominant in the domestic market, but they're single dwelling in Sweden, one family houses. If you look at, as Thomas has said, one of the focuses of Qvantum is multi-dwelling, and it's quite interesting when you go for an interview and people start talking to you about exhaust air heat pumps. And from my experience, when I was at Mitsubishi 25 years ago, they were on Rip Off Britain, and you go, exhaust air heat pumps don't work in the UK. And 2 hours into my interview with our chief technical officer, I was like, oh my God, they actually do work. But it was a case that technology had to advance in the last 20 years, and building fabric had to improve, and knowledge and application of heat pumps has had to improve to the point where you go, oh, you know what? These have got an absolute real sweet spot whereby, you look at the ambient loop and you look at exhaust air heat pump. Many companies we talk to, they're on the fence about which way they should go. They know they should go heat pump, but it's whether they go to an ambient loop or they go an exhaust air heat pump. There are many companies who are looking at developers who are going, where should we go with it? And I think that's where the experience that we bring to the table. I mean, you've mentioned Darren Manley, who's our technical sales director. He's done this not just at Qvantum, but he's done ambient loops at his previous company Dakin for many years, and he brings a wealth of knowledge to that discussion, so we can have an unbiased discussion with developers about where the pros and cons are.
Yeah, it's worth, obviously I came here to have a chat with Darren as well, so just from the listeners, Dakin have kind of been involved in this a long time. It's obviously not Dakin's. I mean, Dakin are a super massive company in the world. In this country, they're probably more known for VRV, but he's got that expertise. I mean, he's one of probably the leading experts in the UK on ambient loops. So it's been nice, and he's the same age as me. So it's always nice to chat to someone my age. So I suppose that's why Qvantum got him. That's why they sort of. You guys have got hold of Darren now, isn't it?
Absolutely, yeah. He brings such a wealth of knowledge and expertise that but he's not just designed the systems in terms of the application. He was involved in the product development, and indeed, coming over to Qvantum, he's been integral in assisting the Swedes in how to design an ambient loop system. The Swedes look at it more of a ground source heat pump application, because it can go down, the QG as we call it. It can go down to -5, -10 degrees water inlet temperature. Whereas when we talk ambient loop, the Swedes are like, how does this go together? And Darren's like, don't you worry guys, I know exactly what I'm doing. And whenever you launch any new technology, there's always going to be bumps in the road. And Darren will talk about the bumps in the road he's had in the last 5 years, whereby, you learn things as you go along sometimes. And he's certainly brought that knowledge to Qvantum.
So would it be fair to say, so developers, you're a good company that developers could, and social housing and local authorities, because obviously, a lot of people on my podcast, a lot of people listening to it are thinking about their own homes. So they're thinking about an individual engineer who can put a heat pump into their own home. But you do heat pumps for homes, as we know. But you've got these good two solutions that developers, social housing, they can come and chat with you, and you can sort of help them understand what exhaust air heat pumps are and what these sort of ambient loop. I mean, do you find people, Thomas, you're very good at sort of talking to people about this stuff. Are people kind of, do they understand what an ambient loop is when you chat to them about it, or is it?
Yeah, they do. I had quite a few discussions by now, and what we learned is that there are two things that we have to start with in the discussion. And one is you can start with one building. I don't need to start with a whole village. I can really say you have a standard building, the average building in Europe, and of course there's many deviations from that, but the average multifamily building has 8 apartments around a shared staircase, typically 4 levels. And that means if you can connect these 8 apartments via one loop, and then typically you go in through the chimney, then the people understand that very easily. And you say, okay, I give you one small heat pump and a tank into each apartment, and I provide heating and cooling and hot water from that. And we do it smart, we do it connected, always on, so we can also make you benefit from time of use tariffs. That's the first one. But then the people start to think, and they are like, okay, so I can do that, but how do I then bring the heat, the base load heat, into that loop? And that's the thing that I didn't see as so important, but it's actually really the second question that you get. And then we have many options. We can start, if we take this single building setup, we start with one air source heat pump on the roof, for example, or one ground coupled heat pump in the yard, and then do some drillings. Or you have a wastewater grid outside the door, and then you can do these wastewater heat exchangers and use those. Or you have a hotel next door. But of course that's conceptual. And then we explain that to them, and they say, okay, but how do I get the right to access the wastewater mains in my street? And that's where then the government relations come in, because that's not organized in the same way in every city, let alone country. And that's where we have to look into, and that's where we have to convince policymakers that this should actually be easy, so that we can do what our colleague Per Rosin always says, sharing is caring. So if we can make the waste heat of the one party the energy source of the other, then we will all benefit. And in order to do that, we have to extend this concept of an ambient loop from one building to many, and even maybe from many buildings to a whole city. So to answer the question in one word, the people, they are very interested, and if you give them this explanation, they understand quite quickly.
I mean, is the complexity then, because let's say we're talking about cities, is the complexity in the infrastructure, getting this infrastructure, the actual, on theory, it's a very, very good way of doing things. We collect waste heat from something, put that into the ambient loop, and then that can heat. We can also cool with all of these 5th gen systems as well. But who are the right people to speak to with getting the infrastructure? Then it's right up at the top. Then is it at the policy level?
It will be the city council in the first place, and that's why we thought we start with one building so that we can make proof of concepts and then convince people, because we can show them that it does work. I do think that also a lot of the other players in the market are not engaging in this solution because it is so complex, and you will probably have project lead times of 1 to 2 years before you can even start, and then after you have organized everything, it will still be another 1 or 2 years. The big project that is now in London here, Silvertown, they aim to have completed the whole construction in 2036, and then you see that this is not done quickly. And that brings me back to the single building, because there's many owners of multifamily buildings that need to change and that have the pain of being subject to change. In Germany, for example, you have the situation, if one gas boiler breaks, according to the current heating law, you have 5 years to change all the heat emitters and heat generators in the house. So that means, if one boiler breaks, you can put one in for repair, but you can't continue to operate the whole building on gas. What do? And the owners are quite concerned. And sometimes the owners are multiple ownership communities, and they are even more concerned. But for them, we have found a solution where we said, okay, we can build in the ambient loop first, and then you're not forced to do anything. So nobody comes and rips out your gas boiler. We just keep that there. And when you're ready, when your gas boiler breaks or you have the money, then we can connect your individual apartment to the ambient loop. And I was really surprised when I presented that for the first time, how relieved the people are when you tell them there is no force in this. We just provide an opportunity for you that you can use whenever you need to.
And who's putting this ambient loop in then? It's obviously a separate...
The construction company. Yeah. Well, there's cooperation partners as much as you today. If you need an air-to-water heat pump and you need a foundation, typically it's not the installer that is doing it. They ask the civil engineer to say, come over and build the foundations.
So it's the QG that you're... in fairness to you're the way you number and your models is quite simple. So your QG stands for quantum ground, doesn't it? And then your QE is quantum exhaust, which makes it a lot simpler.
And then QA, and you have it complete.
Yeah, quantum
then
air.
When we have commercial units, it gets a bit more complex.
So your QG is kind of ready to go. It's this third quarter of this year, is it?
That's right. It's in production in September. We have the first units arriving in October. So very exciting.
And what about in the rest of you, Thomas? Is this stuff going in, like you just mentioned, Germany? So the ambient loops are possibly going to be going in for the future, but is this technology out there already yet?
It's getting more and more recognized and more done. We have maybe a couple of hundred, I'd say below 200, but networks, ambient loops in Germany. There's a website that lists them up. It's Marco Wirtz, a guy who is also creating a software called Empro, and for dimensioning. There's actually quite a few people now working on software to support the dimensioning of these grids. We have one ourselves. We call it the Q Planner, and there is really, it's quite a strong support argument for the technical engineers that need to build these. If you can tell them, but we can help you. We can put up to 3 buildings at the moment, if I'm correctly informed, because it's changing very fast. It's really software in the making that we can dimension together, and then you can plan which main energy source you have, which type of big heat pump, commercial heat pump you take, and how many small heat pumps you can connect to that. And now, from our perspective, we take the quantum commercial units and connect one quantum commercial unit or 2 quantum commercial units, let's say 22 or 50 kilowatts, and that gives us the base load for the ambient loop, brings it to 10-15 degrees, and then the small heat pumps provide the rest. They do the lifting where it's needed and lift the hot water to 70 degrees or so, and whenever you need the cooling, then we can install that. But of course the cooling, that's the other part, then you need some additional infrastructure, a fan coil unit or similar.
So that software interests me. Is that digital twin software, or is it design software, or?
I would not call it a digital twin as of now, but it could become a digital twin. But what we do at the moment is we take the characteristics of the hardware that we have, we put this together with the building requirements, and then you can model a building or 2 or 3 with the thermal load, with the waste heat, and with the amount of pump energy that you need, and with the capacities for the different baseload and booster heat pumps.
Well, that's quite interesting. So just before I came here, I had a meeting in London with a friend of mine who studied at Imperial for his PhD in thermofluids and thermodynamics back in the early 80s. But he's also a developer, so he developed the digital twin architecture for sort of North Sea exploration. Because I think what the digital twin is a massive thing in our industry now. But obviously, whoever wants digital twins have to go to developers, coders, and try and explain this kind of knowledge that they might not know. Not many developers know about thermodynamics.
You can go 2 steps, right? You could say we take a digital twin of each unit, and the advantage of the quantum solution is that all our units are online from day one. And half jokingly, the CEO, Frederick, he says that if I want to know how much my guys have sold, I don't ask sales for statistics. I just go to the service tool and see how many units went online yesterday. That's the reality. So we know how well our units are performing on every given day. And that means also that if you then have an idea of how good a unit should perform, and then you compare that, so then you come with your digital twin, then you compare that to the real operations characteristics, then of course you can say, is that unit operating properly? Has that been designed properly? Has that been commissioned properly?
I'll have to hook you up with a friend, Lawrence.
Yeah, let's do that. And we can also put the link to the planner software into the speaking notes of the podcast, because that is available. Everybody can create a login and then play with it.
Are there any developers? I mean, there's lots of developers in the UK, but are there any sort of that are becoming really interested in what you can do with your exhaust and with the ambient? Is this starting to sort of become a bit more of a buzz around it?
It's becoming mainstream discussion with developers, some very large developers, and we're talking about thousands of dwellings a year, and they're looking, going, where the hell are we going to go? And it's interesting. Thomas mentioned cooling before, because the recent summers we've had, the overheat in apartments is becoming a real issue, especially you haven't got openable windows, and if you look at the air tightness of buildings is getting better and better, therefore overheat mitigation is getting bigger and bigger deal. Now we have a legislation, Part O, specifically targeted to combat overheating in dwellings. So when you think, crikey, cooling isn't a luxury when you're in the 10th floor of an apartment block and you can't open a window and it's 35 degrees outside. That's not a luxury. It's not maintaining 21 degrees year round, but it's, can I sleep at night? And that's one of the things that developers are looking at, that we need to be able to comply with Part O, and it doesn't always start with just increase the ventilation rate, because if it's 30 degrees outside, you ain't going to get anything. So that's becoming a real focus for developers, is actually how they're going to comply. If you do thermal modelling, it might only be 10 out of 200 apartments that would actually need some form of mechanical cooling. But you've got to be able to achieve that 26 degrees.
And we have done a number of webinars with developers ourselves. And typically we had 30-40 people in the room online. I mean, that was right, so not figuratively in the room, but the interest is very high. And interestingly enough, the design, the concept is not necessarily known, but once you explain it, they say, absolutely, that's what we need.
I suppose it's worth, for the benefit of my listeners and the layperson, there's a difference between comfort cooling and overheat protection, isn't there?
There is, yes.
Because obviously people have experienced, I've experienced it in some of my friends' houses, which kind of on paper they're quite modern houses, but if it's 35 degrees outside for a couple of days, it's kind of 35 degrees inside. That's like unbearable. Yeah. So overheat protection is where you kind of get down to about 26. Comfort cooling is where you're sort of cooling it down to sort of lower temperatures and that. But obviously overheat protection is very, very important, especially for certain, especially for the elderly, because it's hard enough, all us fit people. I'm looking at Thomas when I said fit people. Well, and Philip, not so much myself, but it's very, very difficult for old people to be comfortable at that sort of temperature. So this overheat thing is quite a very, very...
No, you're absolutely true, and
good USP for you.
I'm of a certain age where some of my friends are having babies, and in the last couple of weeks you see them looking even more tired than usual, because they might be able to sleep, but these poor newborn babies, so you think vulnerable households can mean anything from someone with a newborn to someone who's elderly or infirm, disabled. There is a lot of different categories you need to think about and how you're going to help those people.
What is the process for a developer? Like, let's think a developer's building, let's say 150 units. Do they come direct to you guys and they get some solutions, whether it's your exhaust stuff or whether it's your ambient loop? Do they come to you, or do they go to a consultancy? What is the sort of process for them?
So most would go to a consultant, a building service consultant, and they would get their advice as what is the what legislation they have to adhere to, and the consultant's job is to be the leading light on how to comply with building regulations, be it Part F, Part O, Part L, etc. Once that that chain of events has happened, then it's kind of down to the consultants to then integrate and discuss with manufacturers like ourselves in terms of what the cutting edge technology is. 2 years Qvantum didn't exist 2 years ago. Now we exist, and we are bringing exhaust air products to the market that have overheat mitigation. We have ambient loop products where ambient loops maybe not so prevalent in the UK at the moment, but they're a hot discussion topic, and we have, as we said, we have the UK expert working for us. So once we've then discussed this with the consultant, they'll look at the employer's requirements, and then they will put forward to the client what the best course of action is. And one of the benefits from Qvantum, from coming from Mitsubishi to Qvantum, is we can talk about multi-dwelling, and honestly speaking, we have no skin in the game, because the two front-running technologies, we have both. So we have no preference as to which way the developer chooses to go. So we can be, as open and honest with, as Thomas has said, the ambient loop, for recovering heat between apartments, between buildings, between different floors, etc. But there are downsides. There is where the developer will look and go, but I have to install an energy loop, I have to install an air source heat pump or a ground loop, and I'm now supplying energy to the apartment in the form of the water that's either being used as a heat source or a heat sink. So that building then becomes, there needs to be an ESCO involved, because you're supplying energy to the apartment. Now Thomas has put his finger up.
Maybe not, because the point is right. The first reaction will be that's too complex from the admin part. But on the European level, and I would need to check what the status is in the UK. On the European level, we have these energy communities now. They are codified into law. This law needs to be transposed into national law, and if that is then the case, then you can have a very simple solution on how to be able to deliver energy even across the boundaries of a lot. And that's typically the problem, right? Everything that you do on one lot is easy. As soon as you want to go into the public domain or across lots and cross the border, then it becomes more complex, and out of a sudden you find yourself in the rule set of an energy company, utility, and that is typically too much. So that would really be a showstopper.
Exactly, yeah. Whereas if you look at an exhaust air heat pump, it's an in-apartment standalone solution. However, you can't get comfort cooling. You can't cool the apartment down to 21 degrees year round. Is overheat mitigation sufficient for that developer? If you're buying an apartment in London and you're paying £500,000 for a 2-bedroom apartment, I think I want to be 21 degrees, But I think there's a lot of discussion with developers in terms of where they're going, and I think it's important for manufacturers to be able to have that open and honest discussion with the pros and cons.
So we mentioned how developers will go to a consultant first, and the consultant sort of decides. Now, are consultants coming to you to get information about current products and solutions? Because I think one of the problems in this country that probably doesn't get discussed enough, I don't know if you can discuss, I can discuss it, is I think there's a skills gap amongst our consultancies in this country. For some reason, consultancies are seen as the reason they exist, because they're supposed to be the experts that people go to. But as we're progressing through this industry very, very rapidly, I'd argue that we have a massive skills gap within consultancies. I didn't know whether you go out to them and say, look, this is our technology, do you want to learn more about it? Or they come to you and say, oh, you've got some technology, can we learn about it? I don't know how that sort of works.
Yeah. I think the industry has changed rapidly in the last 10 years. When I was in consultant sales, as we called it when I was in Mitsubishi, the mechanical engineer was the lead on the project. When I go and visit developers and consultants now, it's the sustainability engineer is the lead on the project, and they're the ones who are leading the project and kind of guiding the project with the developer before the mechanical nuts and bolts, flow rates, temperatures, delta T person gets involved with the project. In terms of what manufacturers do, the CPDs, that's one of the main things that we engage consultants with, is that we'll go and do a CPD on the latest technology. Now, you can only be CPD approved if it's generic, but it is also has to be shown. There's construction CPD, there's CIBSI approved CPDs, and they have to be proven to be of value and cutting edge and new. And most consultant practices will do 1 or 2 CPDs a week, and obviously they have to do so many hours every year in order to maintain their continual professional development. But I think the more manufacturers that offer CPDs on those cutting edge technologies is the vehicle that I see to keep consultants abreast of that. But if you think about ambient loops, they're very easy to talk about in the sense that we've talked about today. If you then get down to nuts and bolts and say, right, what pipe size, what flow rate, are you going to use a pick valve or a shunt pump, and how are you going to control the flow rates and temperatures? It's like, okay, you go into another level of detail whereby, are there many consultants who've actually designed and operated an ambient loop? VRF killed the expertise within the building service industry, because 30 years ago, everyone was designing chilled water systems, and the engineers were God then, and then VRF came in and dumbed down the industry. And I think we're now re-upskilling that industry to deal with water flowing around the building again, because
it's coming back, isn't it? Not?
It's definitely coming back. Yeah, you now have 4-pipe chillers, heat recovery chillers, whereby you're now sizing those and going, okay, but it's a part of the industry that's probably struggled for knowledge, and now we're re-upskilling that side of the industry.
You mentioned something there. I just want so all my listeners understand. You mentioned ESCO. So can one of you just say what that is for a layperson?
Energy Services Company.
Yeah. I mean, because we all use these abbreviations, and I know people sometimes come back, what is that abbreviation? So, do you think, Thomas, obviously you had a very good sort of bird's eye view of the whole of Europe and where it was all going with heat pumps and electrification. Do you think UK are on the right path? Are we going quick enough? Are you allowed to say?
We had a long discussion about that before. So personally, I think that the UK at the moment has really made a leap forward, and many other countries that were advanced, they have slowed down a little. Notably, the German government could have moved faster, and we had this big discussion, which now turns out that it was really actually a campaign against heat pumps, a campaign pretty much paid by the oil and gas industry and vested interest. But it has led to a delay in progress, and this idea that we would have 500,000 heat pumps per year, that's a bit moved outwards. I think also other countries like France, they could move faster. You wonder why there are not many more heat pumps in Italy, especially because of the heating and cooling function that they both have. But it is a good foundation. We are now talking about the latest numbers, I think 2024, we're talking about 24 million installed heat pumps. And that means and of course always depending on how you calculate it, but we have something like 190 million single-family houses and another 25 million multi-family buildings. And so if we have 24 million heat pumps, we're somewhere exceeding the 20 or around the 20% mark, which I think is quite good, because it means that you cannot walk around anymore without seeing a heat pump. The other day I was driving through a rather small village, and I came through a street, and there was on both sides of the street, like every third or fourth house you find an Asos heat pump in the front garden. So now, apart from the fact that we have told everybody how heat pumps work and what you can do with them, you also start to see them now in the reality, in the villages and cities of Europe. So I think it will move faster. I like what the UK has done in terms of being quite robust and not pedaling back when it came to committing towards heat pumps. Quite a few other countries, they still live with this technology neutrality mantra, and my opinion on that one is, if you say technology neutrality, it says you don't want to take a decision, and you're hiding behind that word, and you're avoiding to take the decision that is absolutely necessary to decarbonize heating and cooling in Europe.
Yeah, I agree. It's a funny word, is it? Spark gap in this country. So obviously, you've had a good view of all sorts of countries over your time at the European Heat Pump Association. What's your views on this spark gap thing going on?
So maybe then we should take care of your listeners and explain what the spark gap is. No?
They'll probably know.
They know.
They're very clever listeners.
Very good. Well, then we don't explain it, but it's the ratio between the electricity price and the gas price. And actually, we decided a while ago in Europe, maybe it must have been 2021 or 22, that we needed to take a statement. And so, not out of thin air, but from some consideration, we said the spark gap should be 2. And why should it be 2? If a standard heat pump can achieve a seasonal performance of 4, then you can save half the heating costs if you have a spark gap of 2, because you need then you pay half. And if you're facing the situation that the investment is higher, maybe it's double. At that time, it was quite typical that the investment for a heat pump was double the investment into a comparable gas boiler. So we said, then at least you have some promise to make. If you're the installer, you can tell the end user you will save in operation costs, and so you can recover your investment. Even though the whole discussion on the investment is a bit of funny, because nobody asked for the investment, the returns on investment if you buy a kitchen, and that has also been mentioned many times. But so the spark gap at the moment in those countries that have a high penetration of heat pumps, notably the Scandinavian countries, the Baltics, but also France and Portugal, I think, and Italy, but I would have to look at the map now, as it's always changing. But this spark gap shows that if the spark gap is low, if the people can save operation costs, then actually the likelihood of buying a heat pump is increasing. Then, of course, the second factor is how much is the overall investment, and the third factor is what's the purchasing power in the country. Because I was in Hungary, and we discussed in Hungary with the local energy agency in Budapest, and they said, yeah, but people have so little money, and gas is subsidized, so even the spark spread is okay, but the overall heating costs, the operations costs are so low that you can never recover the initial investment, which is higher. So these three things we have to think together, and that's why I think it's so important that we have one-stop shops that help the end user to understand and help them to move to a total cost of ownership perspective. So spark spread is one, but it's not the only one, it's not the most important one.
So let's talk about this one-stop shop, because it's another sort of a term that's been used for quite a few years now. I mean, what's your idea of a one-stop shop?
I would call it a body that gives support to an end user from general overarching information on the technology, on the options, to assessing your specific problem. So I would imagine that you could go there, you find experts, independent experts, you go there with your plans, your building plans, your existing heat bills, for example, your electricity bill, and you say, I want to change that. What can I do? And they help you in doing that, in understanding which options you have, maybe even make a design, help you analyze offers by installers. So I think they could have a role to play in avoiding those cowboys that make nice offers that are not beneficial to the end user, and then even it could go so far as to check the quality of the final installation.
The problem I see with these one-stop shops is who assesses whether they actually are knowledgeable enough to provide that service. Because what's been going on in the UK, I mean, we've got these schemes like Trustmark, we've got lots of accreditation schemes. I mean, MCS is an accreditation scheme that's kind of supposed to, even if you look on their website, it says this means you've had a quality install. Now, we all know that doesn't go on, and we all know that Trustmark, as far as I'm concerned, hasn't worked. So if you have independent one-stop shops, how does the person going to them know that they actually know their stuff as well? Because it's so complex, because we've got an accreditation system, we've got a qualification system in this country that qualifies a lot of people that arguably aren't competent. I mean, it's definitely going on in sort of plumbing and heating world. You know, we've been doing that for a long time, giving qualifications. So one-stop shops in theory work only if they actually are very knowledgeable and can provide the service.
But of course, I would imagine this has to be a commercial entity. It's not for free, and it's also not by whoever wants to do it, and certainly not done with somebody that has taken a 3 weeks course and then calls themselves an energy advisor, and then they should do it. It should be. I guess. I mean, we have to look into detail if you want to define the qualification. But from speaking as I think, then I would say it could be a civil engineer with the specification in energy assessment. It could be somebody that has worked for 5, 6, 7 years in the field. It could be an installer that has installed 2 heat pumps per week. You know, the same way you can make it, of course, incredibly complex and say, now I want another certification for this. Let's make it a bachelor or a master degree in University College London. You can do all these things, but maybe we can start smaller, and we can say if there are people that can prove that they have a lot of experience in the field, then they could start with that. And I guess there is some learning to be done, which I claim that I know all the answers to that, but the concept in itself, looking at how many people are really uncertain on what they could do, that I think is very important. Because I like this book of Michael Mann, where he talks about the war that we have to fight to stop climate change, and he talks about urgency and agency, the urgency to act and the agency to do something. And the agency to do something has to be given to people. If you are confronted by yourself in having to renovate your building, it's probably too much for you. And then we are talking even to lower income households. It's not everybody has enough time to spend 5, 6, 7 hours per week to discuss with somebody else. Maybe you have people that they struggle with their normal life, but they also need their houses to be decarbonized. Who is doing that? If we could set this up, maybe we start with that. Low income houses first, and we establish it as a municipal service, and then we go in and say, okay, we start renovating those houses, and then we learn from there, and then we roll it out. Could be one option. But the function itself, to provide trust to end users that otherwise don't know if they get the proper offer, that is important.
Well, it's the reason I started. So obviously you can make the installer show this year. Unfortunately, you're doing something quite important elsewhere. But I launched the Guild of Master Heat Engineers. So it was actually you years ago. I think you were being interviewed by Michael Liebreich.
Yeah.
You said about my network of engineers, didn't you? Which was an informal network, and so I've started up the Guild of Master Heating Engineers because it's based around the old original Middle Age guilds. So in the Middle Ages, you had journeymen sort of literally journeying around working for masters, but if they wanted to become a master themselves, they did the masterpiece. That's where that word comes from, masterpiece. And if it was peer assessed, and if it was peer assessed to be competent, you became a master. Now, peer assessment is going on all the time amongst all the top engineers on there. They know who's good. I think you find that in lots of industries. If you're a developer or even a footballer, if you ask a football team who's the best footballer in the team, it might not be the one that all the fans think. But so anyone in their own industry knows who's good. So I've just started that, and that kind of links this one-stop shop thing, because there's so many customers out there who just doesn't know who do they trust, who do they turn to.
Yeah.
But that brings me on to the point of some of these engineers I know obviously are doing domestic retrofits, but they are interested in some of the stuff we're talking about today, like ambient loops. And obviously at the moment we've got developers working with consultants, which obviously are big entities. But I can see in the future some of these there's some passionate engineers out there that are obviously going into people's homes, but I think some of them want to think, well, I wouldn't mind going into this bigger stuff and getting involved with companies like Qvantum and helping these multiple house sort of buildings get a very, very good, because that's what they're about. They're about putting good solutions and systems in. I mean, can you see that as a bit of a future for this sort of stuff?
I think it's a natural evolution. I do. I think if you are putting 2 air source heat pumps in a week, and then you look at someone who's building an apartment block of 30 or 40 apartments, and you think, well, I could probably do an apartment a day, in terms of installing the heat pump, first fix, second fix, etc. You think, well, you know what? Why can't I get involved with that? Now, there's a finance side of things whereby credit will come into it, because if you're going to be installing 10 heat pumps, 5 heat pumps a week rather than 2, but I think it's natural progression. And as you develop more skills, an exhaust air heat pump, for example, you're going to have to learn the ductwork side of things, which was new to me coming in from maybe a heat pump manufacturer. Once I saw the marketing suite and a couple of installations, I'm like, is that it? It's that simple. It's you go to a supplier, like Lindab, and you say, this is what I've got, this is what I need. They cut it up, and then a pallet arrives 2 days later, and it's got all the elbow joints, and it goes from circular to oblong duct, and you've got your insulation. I'm like, I could do this.
All insulated.
Another string to your bow.
I mean, imagine when we have the first masterpiece of a multi-family building, and then we have at the moment 7 distribution companies, right? So we could put them up against each other and say, you check. We do a cross-check of the other countries' engineers if the masterpiece of the Swedes is seen as a masterpiece from the Brits.
Well, this is another thing I really like about these sort of these engineers, because engineers become passionate again. It's a really nice thing for me to see, because for most of the time I've been working, since 1986 or 7 I started. We were seen as road traders. A lot of trades are seen as rogues and cowboys. Now, I can't really speak for other trades, but my trade is bloody complex. If you want to be good at it and remember all the water regs and building regs, etc., it can get very, very complex. And what's happened is with heat pumps become such a big thing now, you've got these engineers that really took on board and become passionate about learning. I mean, they're super, some of these, really, 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 really clever. And I think if you push them stuff to do that's technical, and they're going to be passionate about doing it and learning it. And the other thing is, you do find UK engineers are really interested in what German engineers are doing and Swedish engineers. There's this natural thing of how do they do it? What do they do? And I think that's something in Europe we should be promoting that more and getting these engineers together to spark ideas off each other, because they are really, really good, clever people. And if you find when you see natural engineers together, and it doesn't always have to be in a pub, but it sometimes does generally get into the pub. But all they will talk about is what they're doing, and and I don't even call myself a natural engineer, but I grew up around them, and my grandfather was constantly travelling around Europe, constantly, and that's what he liked doing. He just liked chatting to people that understood what he could talk about, and I think it's something we could probably promote. Or we should promote a bit more, and obviously with companies like yourselves, it's a Swedish company. Obviously with Thomas has got more European contacts than anyone I know. I think it's something you guys could really, really help other engineers do, and build that passion up and keep that momentum going, because there is so much passion out there amongst these engineers. There's passion amongst engineers that aren't that good.
I'd certainly say that is ingrained in Qvantum. This idea that we bring the few engineers that we have today, we bring them together on a regular basis and they talk. And if it's only via Teams, but there is an exchange happening already now, and that of course can be extended on scale.
I think within Qvantum we call them communities. So we have an after sales community, and we have a technical community, and we were talking before the podcast about the hierarchy in Qvantum and how it's very flat structured, and all the engineers feeding in their after sales engineers are feeding into the product developers. And we are, for the exhaust air heat pump, we've done 3 revisions now since we launched the exhaust air heat pump a year and a half ago. We're on to revision B. We've run A plus, and now B, and it's from the after sales community all agreeing that the catch pot should be an extra 10 centimetres higher, and that the pipework should be facing down, not forwards. And we've got the development engineers are going, that's a brilliant idea. So you've got a real closed loop there in terms of what's going on to the field, and the engineers feeding back, going, could you just change this or that? And they're going, yeah, of course we can.
That's good. So you're agile to iterate quickly, aren't you? Whereas some companies will struggle to, because that's too big, if I'm honest, some companies.
One of Qvantum's mantras is that we co-create. That's one of the things that the founding members, so Jesper Jarnhall and Fredrik Rosenqvist and Lars Behlen, one of the things they wanted to do was, we are here to disrupt the market, and you do that by being agile, by developing 3 product ranges in 2 years from virtually zero is unheard of. Coming from Mitsubishi, my colleague from Dakin and Darren, you get a product in 5 years' time if you come to the table, whereas Qvantum have done 3 product lines in 2 years. So being agile and listening to the customer journey and listening to the after sales engineers who are feeding back, going, we had a real problem installing this because of that pipework. Okay, we'll change it.
And what really helps to scale is this software support. The planning tool that is now ready for Sweden, and that is now extended by adding local data from the different other countries, so that you can say, okay, if I have a lot in South London, what's the geology there? What can I do with a or a ground coupled heat pump in that context? That's something that is on the horizon. It's not there today, but we can do that, and then we can of course scale that much faster. And when you learn in one country, then of course the software, if there is learning to be done and modification to be done, is improved for everybody. You would imagine, and now I hope that not everybody is copying that, but it's really the right thing to do it this way, because you have all this these lessons learned and from the different countries, they should be fed back into a product portfolio.
It's interesting. Lessons learned. You asked Thomas at the start of this podcast what attracted him to Qvantum, to leave the Secretary General of the EHPA. And I thought, what attracted me to Qvantum? You know, I was thinking, oh God, am I going to have to answer this question? And I've had the last 40 minutes to think of it. But to kind of bring it full circle, it was, you know, having worked for a large global multinational company, and those wheels turn slowly. With Qvantum, one of the things I've said to a number of people is that a young company and the product design started with the end in mind. How would you, after 20 years of working at Eon and then Nibi and then Mitsubishi, what would you do differently? And Qvantum have done that, which is where, you know, having the ability to dial in to every single system, not trusting your salespeople on how many they sold, but actually going on to the Q support tool and going, there was 5 more systems went live yesterday in the Gothenburg area of Sweden or in Birmingham, Birmingham, UK, by the way. So, you know, but we can dial in and we can see every single temperature and pressure on every single system that's installed in Europe. And we can monitor and track.
How powerful that is has shown at a recent incident. We had some, like a small thing that turned out one customer complained not having enough hot water. Then there was a team that looked at this. They reprogrammed the whole controller, and now it's available for everybody. So there may have been other people that have the same problem. They will never realize that they had that problem because now it's solved, and it's going over the air. And it's not the Volkswagen over the air, which unfortunately is over the auto house, right? We can really beam the new software into the controller's life. Of course, not every day, right? I mean, there is of course certain intervals and so on, but if there is an improvement, it is made available for everybody that uses a Qvantum unit.
So I'm here with Darren Manley. Now I want to catch up with Darren to have a good chat, especially for you listeners that are really interested about the history of heating in the UK and also like sort of technical talk. Now Darren's actually just been doing a bit of a training session for Charlotte Lee at the Heat Pump Association. Charlotte's the CEO, and bless her, she's come down. She wanted to learn a little bit more about ambient loop systems, and I'm going to have a quick chat with Darren because he's a bit of an expert, aren't you, Darren? You've been involved in this sort of stuff because not many people will know Dakin was involved in this. Obviously, people know Dakin is involved in VRV and stuff like that, lots of air-to-air stuff. My family's put in lots of Dakin. So just tell us, what was the Dakin stuff you were working on back in the day?
Well, yeah, I mean, I originally started at Dakin almost 20 years back, looking at the individual air source heat pumps. But around about 2011, we started looking seriously about putting heat pumps into new build apartments. And we started doing that with a derivative of the VRF product, where we had a refrigerant-based system supplying a hydrobox in each apartment. But around about 2018, we moved away from that, and I started working on the development of the ambient loop system, which was effectively taking a modified packaged ground source heat pump unit. So an R32 heat pump with a built-in unvented cylinder. So single unit in each apartment to supply heating, hot water and cooling. We connect that onto a shared loop. But then instead of putting the shared loop down into boreholes, we connected it to centralised air source heat pumps.
And you're the guy that actually developed this for Dakin.
I worked with the factory to develop it. I won't take all the credit, but certainly I pushed the factory over in Belgium to work hard in bringing the solution to the UK.
And I'm assuming, well I know, that's why Qvantum have now got you, because you obviously know quite a bit about this stuff. And obviously with the Qvantum stuff, we're getting the energy from the ambient loop, aren't we?
Yeah, that's correct. I mean, you know, ambient loops is a kind of generalised term. As I explained earlier today, there's a lot of terms. There's ambient loop, there's shared borehole arrays, there's 5th generation heat network, and they mean different things to different people. But basically, an ambient loop is taking low-grade energy and moving it around either a network or around a building. And the temperature of that loop really depends upon where you're getting the energy. So you could be taking the energy from the grounds, and you're probably somewhere like 0 to 10 degrees. You could be taking it from an air source heat pump, and then you're probably somewhere like 20 to 30 degrees. Or you could be recovering it from some kind of waste process, a data centre, picking up from some kind of cooling system.
And that's what you describe as ambient. So what would the 5th gen be if you wanted to describe?
Well, 5th gen is really when you start looking at heating. 5th gen is just a development in terms of temperature. So you've got 1st, 2nd, 3rd, 4th, and what you see is the efficiencies of the systems going up and the temperatures going down.
Yeah.
So 4th gen, you're currently about 60 degrees, but you're at the moment, you previously been using CHP and gas boilers to do that. At the moment, it's centralised heat pumps. But there's still some inherent problems with that. 5th gen is really when you're dropping that temperature much lower. So you've got a kind of neutral temperature going around your network. So that can be the source of both heating and cooling. And then you have a localised device. It could be a heat pump based in a plant room doing a whole building, or it could be a heat pump based in each apartment just doing that dwelling.
So what are the main challenges? If a developer's listening to this and thinks this sounds like a really, really good thing, I want this, are there any challenges they have to overcome? I mean, what's their sort of first things they have to do?
There are some misconceptions about the system. It can be seen by some as complex, but actually when you break it down, it's just a series of really basic hydraulic principles. It can be seen as expensive, but then that all depends upon what you're comparing it to. You know, if you were comparing it to a system where you had a centralised air source heat pump providing 60 degrees to supply to heat interface units, just doing heating and hot water, then the ambient loop would be a bit more expensive. But if you were comparing it to a system where you had that same high temperature heat pump with HRUs, but you then needed to provide cooling, and you were doing that via a set-top box on top of your MVHR unit, or you were doing that with some centralised chillers and doubling of the distribution pipe work, then your ambient loop tends to stack up very well on the numbers.
Yeah, in some cases, I imagine it's cheaper.
It will make it cheaper. It gives you a lot of other benefits as well.
And we've got the technology sort of coming into the UK, well, the quantum technology sort of coming into the UK, so Q3, isn't it? And you've got some things in the pipeline. You're going to be doing some stuff somewhere in the country, aren't you?
Yeah, that's right. We'll be putting units in for some extended field trials towards the end of the year, looking to go live with the product early part of 26.
And if people are really interested in sort of this stuff, is there stuff they can go and see now? Are there places they can visit and think, oh, this ambient loop stuff works?
There are, with my previous hat on from my previous employer, we worked on many projects, and there's literally thousands of apartments connected to ambient loops that are in operation, people living there, and it's not just a one brand concept. You've got multiple manufacturers supplying these heat pumps, and so if Daikin had 2,000, probably Dimplex have got 2,000, probably Kenza have got quite a number as well with their shared Warholm race. And
what about out in Sweden? Have you been out to Sweden and seen what they're doing out there?
Yeah, they go there quite a lot.
And because obviously people are still putting 4-gen systems in, aren't they?
Yeah,
all over Europe still, aren't they?
Yep.
But you're a big fan of ambient loops, I suppose, and that's what your chosen choice would be, rather than 4th gen, which is going to have heat losses, isn't it?
Yeah, I would. I mean, any heat pump's a good thing, right? But when I look at 4th generation, you're not solving all the issues. So I look at it as more of a stepping stone away from centralised boiler plant and CHP engines. So they swap that part out to use a heat pump. So we've got rid of gas, we've electrified the system, but you're still inheriting the problems that system had in terms of using higher distribution temperatures to move the heat around the building. So, it's still maybe reduced at 60 degrees, but at 60 degrees you're still suffering quite a lot of heat losses going around the network. And when you've got HRUs, it also means you've got constant circulation around the system. So if you look at your plant room to your furthest HRU, you've always got to have circulation to that point at 60 degrees, should the end user turn the tap on. They can't wait half an hour for the hot water to get there. It has to be there within 45 seconds. So you've always got that heat loss. So when you look at the combination of your heat pump running at its top end of flow temperature to maintain the thermal stores 24/7, you then look at that circulation giving you sort of circa 30% losses. That has quite an impact on the delivered efficiency.
For the people that get involved in putting the actual ambient loops in the ground and that, I mean, is it a seamless operation, or is there a bit of skill involved in that, or is it nothing we have to sort of worry about.
Well, it's all about experience and working with the right people. So, I mean, if you're looking at ground source design, it's about working with people that can dimension and size the borehole arrays correctly. And of course, we have our sister company QSD that are able to offer that service. And of course, then you need to do thermal response testing to actually, you do the theoretical about what you think you're going to get, and then you do the testing with the thermal response tests. But that's when you're looking at the ground. If you're looking at other types of systems where we spoke about using the central air source heat pump, it's really key to partner with people that have got experience in this field and know what they're talking about. And that's one of the things that I like to think that myself and some of my colleagues brought to Qvantum.
When I was chatting to Thomas mentioned about using waste heat, and it's something we hear sort of talked about quite a lot. I mean, what are the sort of common waste heat sort of sources? I mean, is there going to be a day where obviously the sewer systems of large systems contain lots of heat. I mean, can we extract heat from them with these ambient loops?
Yeah, I mean, if the right infrastructure is there, you can harvest heat from practically anywhere. Sewer pipes is one of them. If there's any process requirements, so they may have mentioned there's a big 5th generation network going in East London, and they'll be taking waste heat from the Tate & Lyle factory. Of course, if you had a development where there's a data centre anywhere within the vicinity, they are huge producers of heat because they have a huge demand for cooling. And you also get other types of sort of more usual development where you might have had, let's say you had a department store that's had a change of use. The shop is closed down, they're building out apartments, but at the bottom of it they still have a supermarket. Supermarkets have a big requirement for cooling. That means they produce a lot of heat.
And then we haven't even talked about rivers. I mean, we have the Thames here, right? So every building next, left and right of the Thames could be heated by just putting slinkies into the Thames or into the walls of the harbours, for example.
You'll get people skating on it again, Thomas.
Yeah. I mean, there's been a lot of projects over the years, going back quite a long time. Using water source heat pumps, but then there's also some newer projects at the moment at quite some large scale where they're taking water from underground reservoirs and things like that.
Mines, there was a mine water project. The old mines, they're good sources.
Yeah, there is a project going on at the moment, I think, in Cornwall, isn't there, with the mines?
Right, there's a few, actually.
Well, Darren, thanks ever so much for coming on Beta Talk and giving us a bit of a technical insight into what's happening at Qvantum. Thank you very much.
You're more than welcome. Thanks.
Well, it's been a fantastic day chatting to you both. Thomas and I are going to go out and have something nice to eat in a minute, aren't we, Thomas? Philip, thank you ever so much for showing me around your place today. It's always nice to come and see what's going on. And thank you very much for coming on Beta Talk.
Thank you.
Thank you.